Hello everyone. I am Swetha Nandana, a second semester student currently pursuing Masters in Construction Engineering and Management at CEPT University. My student code is PCM 24409. The second semester study of Construction Project Execution, Monitoring and Control aims to groom the building construction managers to observe, analyze, and reflect on the construction processes performed at various construction sites. I will be today presenting you our project, the redevelopment of railway station. The redevelopment of the railway station is a transformative project located in Ahmedabad and aims at enhancing its role as a critical transportation junction connecting railways, metro lines, and the upcoming high speed rail network. By blending contemporary design with cultural heritage elements, the redevelopment seeks to improve passenger experience and boost the city's economic growth. The project focuses on integrating modern infrastructure with sustainable technologies to create an eco friendly transit environment. The features include a world-class transport hub, spacious waiting deck, smart ticketing system, metro, BRTS, and bullet train connectivity. The project cost is estimated at 2,400 crores, with the project area spanning at 125 acres. The type of the contract is EPC, and the completion timeline is expected by 2027, which is 36 months as per the contract. The concourse level is 54,900 square meters with retail and amenities. The MMTH building, which is the Multi-Modal Transport Hub, integrates trains, metro, BRTS, and a bullet train. Two 16-story buildings for offices and commercial use. It is a brownfield redevelopment project and a joint venture which the contractor won at 2,383.59 crore in 2024. The objectives include providing a green rated station with minimal environmental impact, enhance passenger comfort and experience, ensure a safer station, promote and increase commercial growth and business in the city, generate revenues for Indian Railways, and improve the viability of stations. Pre-construction activities. This section includes all the pre-construction activities and analysis that are involved, which includes the water requirement analysis. Borewell serves as the primary water source for the batching plant, labor colony, and MMTH. At the batching plant, specialized borewell supplies water for concrete manufacturing, curing, and other building activities. The drinking water is supplied through water cans with a daily consumption of 5 water cans for the labor and the lab personnel. For sanitation purposes, water from the borewell is used. At the labor colony, a borewell meets the labor colony's bathing needs. Two water tanks supply water for household and sanitary purposes, one water tank for drinking. At MMTH, the depth of the borewell is 500 feet and the pump power is 10 HP, and the cost of setting up the borewell is rupees 5 lakhs. One water supply tank is provided for drinking purposes, and also few water cans are present at the excavation site. Staff office building, two water tanks are provided, and a steady supply of water for drinking is provided, as well as for washing and for general office use. And for electricity, a DG is present at the batching plant, MMTH, quality lab, as well as the elevated road. And for quality, a well organized and established quality lab is set up near the batching and mixing plant, conducting various tests. Also, there are various approvals which are taken for the redevelopment of the railway station project, which includes groundwater approval from the Central Groundwater Department Authority, pollution control from the State Pollution Control Board, Environment Management Plan, Environment and Housekeeping Management Railway Board, as well as the permission for tree cutting, which is from the Forest and Wildlife Department, Gujarat. So the different elements in the site mobilization includes contract award, shifting of railway offices, identification and shifting of utility lines, protection of site and demolition of dispensary and the parcel buildings, demolition of the railway building, installation of batching and mixing plant, and the establishment of temporary offices as well as the quality control lab. Now talking about the machine and equipment at site. The layout plan is divided into 6 zones and the tower crane is marked in zone 5. Bar bending machines and bar cutting machines are distributed across multiple zones. The power supply lines, distribution boxes, and DG sets are also strategically located. There are two different types of DG sets. One provides electricity to the different distribution boxes, whereas the other provides electricity to the tower crane in the center. Now, talking about the equipment availability versus the demand table. This table shows the availability and demand of various construction equipment. In several cases, the demand exceeds the available equipment, such as for the bar bending machine and diesel generator, which could lead to potential shortages. Items like the anti-smoke gun and dewatering electric pump have no available units, indicating an urgent need to procure them. The Linear Responsibility Chart (LRC) is a structured tool that defines work responsibilities, assigning roles, authority levels, and resources to specific tasks within a project. It enhances communication, coordination, and efficiency by clearly outlining relationships between project activities and ensuring clarity in roles. A total of 37 quality related activities were identified, in which 12 are defined in the pre construction stage, 20 in the ongoing construction stage, and 5 in the post construction stage. An LRC was prepared for client, contractor, PMS, and third party and design consultant. The LRC of the PMS and third party, as well as the contractor, are clearly defined in the following slides. This is the organization chart for the PMS, that is the authority engineer, as well as the third party testing agency. The personnel that are involved in quality from the PMS side are the chief resident engineer, principal quality engineer, followed by the senior quality engineer, and the principal safety engineer. The personnel who are involved from the third party testing agency in the quality related activities are the quality manager, followed by the senior quality engineer. Now, talking about the roles and responsibilities of this personnel, the senior quality engineer monitors material sourcing and testing, ITP review, and statistical analysis and reporting. Principal safety engineer follows the safety compliance and quality assurance, risk assessment, and hazard management. The chief resident engineer is involved in material and workmanship control, conformance management, and training. The quality engineer is involved in the quality assurance compliance, documentation, and reporting. The testing engineer is involved in material testing and validation, field and laboratory tests. Now, after doing an analysis, the plus delta, in the plus analysis, the clear allocation of the roles and efficient specialization are involved. And in the delta analysis, limited PMS role in external coordination and limited third party involvement in documentation are identified. In the organization chart of the EPC contractor, the personnel which are involved in quality related activities are project director, general manager, quality department, assistant manager, followed by quality engineer and senior engineer, design director, planning engineer, building engineer, and surveyor. Project director oversees QMS effectiveness, allocates resources for quality control. The general manager supports QA/QC in quality reporting, resolves customer complaints. The assistant manager is involved in developing and reviewing the quality plans, monitor and report the project progress, and conduct site inspections. The quality engineer inspects materials, oversees lab equipment calibration and records. The senior engineer identifies, tests, and ensures the compliance, document the results. The design director develops working drawings and specifications, reviews and validates the draft drawings. Planning engineer develops method statements, track progress, assist planning and QAP development. The structural engineers develop survey plans for specifications, inspect site. The design engineer develops technical specifications, ensures design consistency, and the site engineer oversees site compliance, conducts site inspections, and prepares the reports. Personnel which are involved in the quality from the head office are the chief managing director, who oversees the critical project aspects, ensures project aligns with the objectives, the managing director, who ensures on site work quality and monitors the construction, and the corporate quality head, prepares detailed post audit reports. This is the linear responsibility chart of the contractor, which outlines the distribution of responsibilities for quality within an EPC firm and a contractor organization. It highlights the involvement of project managers, quality engineers, and auditors, ensuring compliance with quality control standards. The plus analysis includes clear allocation of roles, construction quality planning, well-defined reporting mechanism, and strong pre-construction consultation. Whereas the delta analysis includes underutilization of execution roles in post-construction and delayed approval process for quality plans. Quality control laboratory is a crucial part of a construction site, ensuring that all materials and processes comply with required quality standards. It plays a key role in testing construction materials such as steel, concrete, aggregate, and soil to verify their compliance with project specifications and legal requirements. By conducting thorough material analysis, the lab helps detect potential issues early, allowing for timely corrections and preventing defects. The quality control lab for our project is positioned at the batching and mixing plant with a total area of 252 square meters, which includes a security headroom, quality control manager room, which includes persons from both the contractor as well as the PMS, engineer's room, cement testing room, and the equipment testing area as well as a washroom. After thoroughly going through the layout, a few areas of improvement are suggested, which includes a revised layout plan, material storage space, equipment backup, and the test platform for certain equipment such as the aggregate impact height, as well as the fire safety measures. Quality organization structure. The chart illustrates the hierarchical structure of the quality department. At the top is the senior leader who is responsible for overseeing the quality control. Then the assistant manager who makes quality related activities specific to each site. The quality engineer then serves as a link between senior management and the various teams on site. And then the senior engineer who is in charge of supervising both laboratory and field operations. List of equipment and quality law. As per the table, the equipment available at the site matches with the demand as per the contract. Calibration schedule of equipment. The calibration schedule of every equipment at the site happens yearly, whereas the digital compression testing machine and the batching and mixing plant, the calibration happens for every 3 months. These are few renders prepared for the QA lab in softwares. The rendered visuals present a well organized and functional layout for the quality control lab at the site. The 3D isometric view, along with the sectional perspectives, showcases dedicated spaces which are designed to streamline quality monitoring process and ensure effective communication between various departments. These are the conclusions derived from the above three assignments. Pre-construction activities. The project relies on diesel generators due to delayed power connections. Although the water system with borewells and an RO plant is solid, equipment shortages may pose future risks. Site mobilization was well sequenced with demolition surveys and the setup of a batching and mixing plant and a labor colony. Efficient budgeting, early approvals, and regular status tracking helped reduce delays and ensure regulatory compliance. Linear responsibility chart. The PMS handles quality and documentation while third party provides validation, though limited cross checks may cause compliance issues. Contractor leads inspections and reporting, but delays due to excessive consultations affect progress. Empowering on site roles and streamlining approvals can enhance efficiency. QA/QC lab layout. The 252 square meters QA lab is near the batching and mixing plant with a curing tank, but lacks proper storage and fire safety. Better space use and safety upgrades are needed. Regular calibration and backup equipment are crucial for continuous and reliable testing. Thank you.